Hello everyone, today is day 21 of solving a LeetCode problem every day, and today I'm going to be solving, or I've already solved, merge two sorted lists. So you're given the head of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the node of the first two lists and then return the head of the merge linked list. So for starters, it's saying merge the two linked lists into one sorted list, and then these lists are also already sorted for us, and the list should be made by splicing together the nodes. So it means that we're not creating new nodes, but we're just reusing these existing nodes. So for example, in this case, we have 1, 2, and 4, and 1, 3, and 4. We get 1, 1, 2, 3, 4, 4. And the way this basically happens is we compare these first two nodes. They're equal, so we add whichever one. We add this one, or in this case, this one was added. And then we move a pointer to here. And we compare these two. This one is less, so we place this one, move a pointer here. We compare these two. This one is less. We put this one in here, and we move a pointer one to the right. We compare these two. This one is less. We put it, move a pointer to the right, and then these are equal, so this gets added and that gets added. So I mean, that's pretty much like the general idea behind how to solve this. I mean, I think it's pretty intuitive. The way I did it is I first started by creating a dummy node, and I also set this dummy node to be the current node. And this dummy node just pretty much helps, work, or helps us process a linked list, because sometimes it's a lot harder when you start from the first node itself. It's sometimes easier just having a dummy node in the beginning. But anyways, now we have a test. Now we have a while loop, and this while loop is gonna run while list 1 and list 2 are not none or not null. And then we have two cases in here. Either list 1, the list 1 value is going to be less than the list 2 value, or the list 2 value is going to be less than or equal to the list 1 value. Now, if this case is true, we just set current.next to be list 1. So that pretty much, if for example, if this was the beginning, dummy.next would be the very first node in list 1, which would be the one in this example. Otherwise, it's the exact same thing here, except we're doing it with list 2. And then here we just are pretty much incrementing the pointers. And here we're just saying current is equal current.next. So we're incrementing the pointer in the output array. Then here, this is included here because at the end, there's a possibility, or there's usually going to be a leftover in one of the arrays. Because for example, you might run out of list 1 elements, and now list 1 is equal to none, but there's still list 2 elements that need to get added to the end of the array. And this is what this does right here. So it sets current.next to be either list 1 or list 2. And for example, if list 1 is none, it would skip this and check if list 2 is true. And it sets current.next depending on that. Then finally, we return dummy.next, which is just the new head of the array. So let's go through a quick test case. Let's see. So let's say we have 1, 2, and 4, and 1, 3, and 5. So basically what would happen is, let's also create this new list, but we begin this. So list 1 is currently 1 and list 2 is currently 2. This is false. So we come over here, current.next, which is currently this dummy node that I'm just not going to put in here, but know that there is a dummy node in this new linked list. It's going to be equal to list 2. So over here, it's going to be a 1. And then we say list 2 is equal to list 2.next. For our purposes, I'm just going to remove it just so we remember we're currently at the 3, but just remember that it's not actually getting removed. Like, it still exists. It's just here now. Anyways, now current is equal to current.next, and that just pretty much says that now we're at 1. Now we go again. So we have list 1's value less than list 2's value is true. So here we set this to 1, and we remove this. And list 1 is equal to list 1.next. That's pretty much what we just did. And current is equal to current.next. So we're at this 1. Now we compare these two values. The 2 is less. So an algorithm here, list 1 values less than list 2 values. So current.next is equal to list 1 dot next, or list 1, sorry. Then list 1 is equal to list 1 dot next. So we pretty much just remove this. Now if I just speed forward a little bit, we add this 3, then we remove it, and then we add this 4, and we remove it. Now notice that once we add this 4, list 1 is now equal to none. What this basically means is that now we've exited this while loop, but there's still this final 5 that we need to process. So here we say current.next is equal to list 1 or list 2. List 1 is false, so we move on to list 2. List 2 is not, list 2 does have a value, so now it gets added as the next. Cool. So time complexity of this is going to be linear, and the reason why it's linear is we're processing each element just once, and space complexity is constant because we're not using any extra space. So yeah, that's my solution for the day.